You were part of the team that worked on these experiments, the BICEP experiments, or the background imaging of cosmic extragalactic polarization. Rolls off the tongue completely. I want to talk about the science and engineering aspects of these experiments. How did you set up these experiments? What did you observe, and how did that confirm cosmic inflation?
Well, so I should stop right there and say it hasn't confirmed cosmic inflation.
Okay.
In fact, the title of my book, my first book, is called Losing the Nobel Prize. We would have won the Nobel Prize, and that's the only sense that we can really say we lost the Nobel Prize. So losing the Nobel Prize it's based on a telescope that I co-created, invented at the South Pole. So if you're watching, there's an image of it on the cover of my book. And that telescope was placed at the South Pole in order to effectively see if we could see this pattern of polarization. So this I started in the year 2000, so it's now in its 25th anniversary year. It's been upgraded just like your iPhone or Android gets updated every year to the latest, greatest model with more pixels and a better camera. We too have done that, or the team has done that, going from BICEP, the original one that I invented and built and installed at the South Pole, all the way up to BICEP, the fourth generation, which is called the BICEP array, which I'm not involved with anymore, but very similar people, very similar science goals. And because we didn't confirm it, although we claimed originally that we did detect this signal, this imprimatur, the pattern that would be there inexorably only if and only if inflation took place. Now, we were mistaken. That's why it's called losing the Nobel Prize, not winning it. We actually saw, instead of seeing the effects of a singularity or the inflationary origin of the universe, which would be a radically explosive process that produced not only heat and light, but also waves of gravity, gravitational radiation. That's what produces the unique polarization pattern. We didn't see that. We saw instead these microscopic grains of dust, which are effectively like micrometeorites. And so I want to point out to your audience that on my website, briankeating.com/YT, you can go there and join the channel as well. But I do give away these meteorites to folks that join my mailing list, which you'll get information about my podcast, my guest, upcoming guest, and cool news about the universe, totally free. And I give away a lot of stuff on there. But if you have a .edu email address, if you're a student, I love you guys so much, and you live in the USA, I want to really make sure that you guarantee to get one of these little meteorites, these beautiful meteorites that I have here. But if you imagine, and that's if you go to briankeating.com/edu. Now, if you imagine these things shrunk down to the size of dust particles or iron particles, like filings in a magnetic field demonstration, that's actually what we have in the galaxy. See, this object this meteorite that I'm showing here, came from the explosive blowing up of a supernova long before our sun even existed. So these meteorites that I give away are about 4.5 billion years old. And they actually trace themselves, which is older than the age of the Earth. So they actually date to a pre-existing primordial solar system. And so on the one hand, we didn't expect these particles to create as big. We knew that they would be there. We just didn't think they'd be so pernicious and so exactly, impersonating of the signal that would be there if we saw the inflationary gravitational radiation. So these objects align in the Milky Way's magnetic field, just like the needle in a magnetic compass, an old-fashioned compass. The Milky Way has a magnetic field, our galaxy has a field, the Earth has a field, you and I have tiny magnetic fields, etc. It's very hard to get rid of magnetic fields, very hard to shield magnetic fields. If you have a piece of metal, you can make a Faraday cage so your phone won't get any signals, but you can't actually use that same Faraday cage to block out magnetic fields. If you put a compass inside of what do they call those little bags that Faraday cages that people that are super paranoid about the government spying on them, they put their phones in every night, and they probably still don't sleep that well. But the magnetic fields in our galaxy are impossible to really screen out, and because of these materials are still floating around, not just in our solar system but in the entire galaxy as a whole, we were susceptible to seeing the orientation and polarization produced by them. And that's what was so, as I said, pernicious, because it exactly mimicked the signal we would see if inflation took place. So although the team, I wasn't invited to it, but had a big press conference at Harvard and made newspaper headlines on every major newspaper, CNN, MSNBC, Fox News, all the different, channels it was featured in. And yet we essentially made a mistake in our claim. We didn't blunder. We didn't I forgot to, my thumb was over the lens of the telescope. I didn't take the lens cap. We didn't make a stupid mistake. In fact, we measured more precisely than ever this signal from an astronomical source called, cosmic dust, particles of dust in our galaxy. And we still have, the team still has, the best constraints on the inflationary epoch that have ever been measured. We're trying to beat that now with my team on the Simons Observatory. And we hope to have our first data. We've already collected our first data set last year even. And we hope to actually release the data in the upcoming year or two. And that will be even more sensitive than the current record-holding BICEP experiment. So it's very important to realize it wasn't a blunder, it wasn't a mistake, it wasn't fraud, it wasn't p-hacking, but it was done in essentially the consequences of what's called confirmation bias, which is a very, very disturbing trend that all scientists can fall victim to, including myself, which is that you tend to want to see things like even you kind of mentioned or hinted at, maybe we did see it, or this is how did it confirm the inflation, and that's fine. I think a lot of people, even professional physicists, when they meet me, sometimes they're like, "Oh, you were part of the team that detected inflation," and I'm like, "Well, no, you obviously haven't read my book, or we didn't detect it. If we did, I'd be maybe having some share of a Nobel Prize." So the effect was so ingrained in both scientists' minds, but in civilization's minds, because it was so incredible and compared to the greatest discovery of all time, the detection of the Big Bang, that people still believe it's true. And that, again, is a symptom of confirmation bias. People do want to see what they want to see. It's very hard to dislodge the notion from their minds that their evidence might not be what they think it is.